Welcome to the video on Pythagorean's theorem and word problems. So Pythagorean's theorem is that in a right triangle, the hypotenuse squared equals the sum of the sides squared. So it's often written as a squared plus b squared equals c squared. So we have two examples here where we're asked to find the missing sides. So for this first one, we're given both legs and we're missing the hypotenuse. So we know x squared equals 1 squared plus 7 squared. So x squared equals 1 plus 49. X squared equals 50. So x will equal the square root of 50. For the second one, we're given the hypotenuse in one leg. So our hypotenuse squared, 5 squared, equals y squared plus 3 squared. So 25 equals y squared plus 9. We'll subtract 9 from each side to get that 16 equals y squared. And then when we take the square root of both sides, we'll get that y equals 4. So Pythagorean's theorem is going to be really useful for a lot of geometry problems. So next we have angles of elevation and depression. So they'll talk about these a lot in word problems. So an angle of elevation is the angle between the horizontal and something above it. So you start at the horizontal and then you'll draw your angle, and this would be your angle of elevation. And then an angle of depression is an angle between the horizontal and something below it. So here, this would be your angle of depression. So here we have our first IB practice question where the calculator is allowed. It says an airplane is flying at an altitude of 500 meters when the pilot notices that the angle of depression to the airport is 26 degrees. How far away is the airport at this moment? So for word problems, you want to start by drawing a diagram. So we have an airplane. You can just label it as airplane. It's flying at an altitude of 500 meters. So this height here is 500 meters. And then the pilot notices that the angle of depression to the airport is 26 degrees. So your angle of depression would be measured from the horizontal down. So this is going to be 26 degrees. And that would be to the airport. So now we have a right triangle. You could draw your right triangle here or where these dashed lines are. You could create your right triangle. So our horizontal lines are parallel, and when you have two parallel lines with a line cut through them, a transversal, then these alternate angles are going to be congruent. So this angle is also 26 degrees. So this is what you want to do to draw your diagram. You'll label and you'll put all of your measurements onto your diagram. And now we want to label what we're looking for. So we're looking for how far away the airport is at this moment. So the airplane to the airport is what we're looking for. So we'll label that X. So we're given an angle and we need to find our hypotenuse. So from this angle, we have our opposite side and we're looking for our hypotenuse. So when we think about our SOHCAHTOA, the function we're going to want to use is sine because we have our opposite and we're looking for hypotenuse. So our sine of 26 degrees equals our opposite, which is 500 meters, over our hypotenuse, which is x. So to solve for x, we'll multiply both sides by x, and then we'll divide by the sine of 26. So x equals 500 meters over the sine of 26 degrees. So that will be approximately 1,140.6 meters. So to ensure that you get full points, I would write out exactly what your answer means. So I would say the airplane is 1,140.6 meters from the airport. And that's your answer. Now we have our second IB practice question where the calculator is also allowed. It says Sam is standing 10 feet away from his favorite national monument. It is 555 feet tall. Sam is 6 feet tall. What is the angle of elevation from the top of Sam to the top of the monument? So we'll start by drawing our diagram. So we have Sam, and he's 10 feet away from his favorite national monument. So we'll say some monument. And the monument is 555 feet tall. Sam is 6 feet tall. And it wants to know the angle of elevation from the top of Sam to the top of the monument. So we're looking for the angle from the horizontal to the top. So this is theta. So we can draw that triangle by itself down here. So we need to subtract 6 from 555 to find the difference in height from the top of Sam to the top of the monument. So that would be 549 feet. He's 10 feet away from the monument, so this is obviously not drawn to scale. And we're looking for theta. So in our SOHCAHTOA, we have our opposite and our adjacent relative to the angle. So we're going to use tangent. So our tangent of theta equals our opposite, 549 feet, over our adjacent, 10 feet. So to solve for theta, we'll take the inverse of tangent. So theta equals tan inverse of 549 over 10, which is approximately 88.96 degrees. So because he's standing so close, he has to look up really high, almost to 90 degrees, to be able to see the top of the monument. So for your answer, we'll say the angle of elevation from the top of Sam to the top of the monument is 88.96 degrees. And that is your answer to this problem. So in summary, we have some important equations. Our Pythagorean theorem is very important. It's a squared plus b squared equals c squared, where in a right triangle, the hypotenuse squared equals the sum of the sides squared. Our angle of elevation is the angle between the horizontal and something above it. The angle of depression is the angle between the horizontal and something below it. And for word problems, we draw a diagram, we label what's given, we assign variables for what needs to be solved, and then we solve the problem. That's all for this video. Thank you so much for watching.